Hello, my name is Janvi Rajnikant Patel and I am student in Department of Construction Management at University of Houston. I am currently pursuing the course named Decision Making and Risk Management under the instruction of the Dr. Professor Liu Gao. Today, I'll be presenting my project on safety incident tracking and risk mitigation planner. This project delved into the proactive safety management techniques to mitigate risk in construction environments, combining the data driven methods such as Monte Carlo stimulation and risk assessment metrics. So, before I start, I would like to express my gratitude to Dr. Professor Liu Gao for his guidance throughout the project and throughout the course. So in the video, I will walk you through the main components of the project of the presentation, starting with the introduction and the objective, followed by the data analysis, decision-making framework, strategical recommendation for the enhancing safety in construction environment. Additionally, I'll be demonstrating the use of a Excel for some techniques. To begin, let me provide you an overview of the project and its objective. The construction industry is very risky. So, with the frequent safety incident with the frequent safety incident impacting both worker and the well-being of the project performance, traditional safety management methods such as manual incident report and hazardous checklist are often reactive and insufficient to address the complex risk present on the model construction site. The primary objective of the project are as follow: track, analyze safety incident, evaluate key risk factor, develop risk mitigation strategies, enhance the decision making. Now let's move on to the data analysis and the key findings of the project. The data set used in the project is stimulated for the purpose of demonstrating the risk mitigation technique and the Excel. So it includes the safety incident recorded over a 1 year of a period for a multiple construction site. And the key variable includes the incident type, servitory levels, root causes, co-reactive actions like a training equipment repair or inspection resolution status. Through the analysis, several findings emerge: incident frequency, which is most incident are medium of servitory and highlight area for improvement in safety protocol; root cause analysis, which is the human error; and the resolution trends. Now let's talk about the method used. First is Monte Carlo stimulation. Using Excel's normal.inv function, I stimulate the thousands of a risk scenario to predict the potential future incident. This technique highlights the most likely outcome in aids in planning preventive measures. This matrix, talking about the statistical analysis, I applied statistical methods such as calculating the average and the standard deviation to analyze the incident severity and frequency. This insight helped to identify the pattern and guide the implementation of the target inventions. Now, let's talk about the risk assessment metrics. This matrix categorize risk based on their likelihood and the survey. Priority, uh, prioritizing, uh, Prioritizing the area that require immediate attention. It provides a visual framework to help safety manager to allocate the resources efficiently. Now, if we talk about the Excel work, let me show you the Excel model which I developed. First, let's talk about the incident log. This incident log has a date, time, location, type, survey, description, action, root cause, and the status. If we talk about the risk assessment metrics, It calculates the risk score based on the incident and the likelihood and the survey tree, like this. Now, if we talk about the key performance metrics, with the use of a VLOOKUP, we can find which most severe incident type here. Total number of incident and highest incident score can also be found. Now, if we talk about the Monte Carlo stimulation, the stimulated survey tree and the risk score was found by using Monte Carlo stimulation using normal.ind RAND 321. Now, statistical analysis also found using the standard deviation and countif function. With the help of that, we can find the probability of medium risk, low risk, and the highest risk. Now, let's move on to the strategical recommendation. So, based on the data analysis and the insight gained from the decision making framework, this recommendation can be taken into consideration. First is enhanced training program. Focus on the reducing human error through the regular role specific safety training and conduct the stimulation based drills to improve the emergency response. Improving in the equipment maintenance. Improving the predictive maintenance using the real time monitoring tools and improve the frequency of the equipment inspection also. By strengthening the communication protocol like using the mobile apps and the communication tool for immediate hazardous reporting and ensure the daily briefing cover site specific risk can reduce the incident at such levels and can make a very safety environment at the site. If we talk about the proactive risk identification, we can adopt such advanced risk assessment tools like utilize the Monte Carlo stimulation and dynamic risk assessment to prioritize the predicted risk. Integrate the IoT sensor to monitor the environment factor and worker activity for a real time. Now, if we talk about the foster safety first culture, we can establish the safety committees to ensure the company wide adherence to the safety protocols, and the main goal of any construction should be safety. So these strategies will help to reduce the safety incidents and to reduce such incident and create a proactive culture in the risk management. Now, let's summarize the key findings. In summary, this project highlights the importance of leveraging the data-driven method for safety management in construction by identifying the key risks like human error and equipment failure, and utilizing tools such as Monte Carlo stimulation and risk assessment metrics. We can make a proactive decision to improve the safety outcome. The integration of advanced analytic method and user-friendly tools such as Excel ensure a systematic approach to a risk management. This is not only reduce the likelihood of the incident but also foster a long-term culture for a safety in construction environment. Thank you for your attention.